Hello, this is Mr. Frank, and welcome to the next video. This learning target is I can solve scale drawing problems. So let's get started. I'm going to draw the Eiffel Tower. All right, here's one line, here's another line. I'm going to draw the actual size of the Eiffel Tower, so I'm keeping drawing. Oh, you know what? I don't have a piece of paper that big. My computer screen is not that big. So let's just make this easy. I'm going to draw a smaller version of the Eiffel Tower because I can't fit it on one piece of paper. So boom, there it is. There's my drawing of the Eiffel Tower. It looks like the Eiffel Tower, but it's a lot smaller. And this is something that's known as a scale drawing. Notice that it's not warped in any way, so I shrunk it so that it's proportional, where the height is shrunk to the same amount that the width is shrunk. So it really looks like the Eiffel Tower. And that's known as a scale drawing, which is a lot easier to walk around with and to show people my great artwork than if I walked around with a life-size version of the Eiffel Tower. So that's what a scale drawing is. It's a proportional drawing, a two-dimensional drawing of an object. Now, there's also something called a scale model, which I'll show you in this video as well, and that's where it's three-dimensional, where it comes a little bit more to life and it's not just on a piece of paper. Let's take a look at, we see drawings all the time, scale drawings and models all the time, so let's take a look at a few. I know I love my Google Maps. And this is a scale drawing. It shows me proportionally what the roads look like, and thankfully it helps me get to where I need to get to. Here's a scale drawing of the inside of the Viking Stadium. So you can see where your seat might be. You can make sure you're getting a good deal. You can see what your sight lines are. It's two-dimensional, so it's a scale drawing. This one's three-dimensional. An architect might use this to show what he or she is going to build. And it's easier than building the actual house and showing people. So that's a scale model because it's three-dimensional. And, oh, I love this one. This is a scale model. This is over here on the left. That's Mini-Me. And this is Dr. Evil from the great movie Austin Powers. If you haven't seen it, it's a classic. It's PG-13, so if you're not 13, make sure you talk to your folks about watching it. All right, so scale drawing and models. They're used to represent objects that are too large or too small to be drawn or built in actual size. But Mr. Frank, you've only shown us stuff where the scale drawing or model is smaller than the actual size. Why would you actually do something bigger than the actual size? Well, here's one. If we're studying bugs, we probably want to make it bigger so we can get the detail and see the detail we want. Or let's say we're presenting to a group and we want to show them a picture. So here's a scale drawing of a bug that's enlarged. I don't like bugs, so let's get rid of it. SWAT! All right, we got rid of it. No more bug. All right, so we talked about vocabulary. So the scale is the ratio that compares the measurement between two objects. So we saw that in all of those drawings where the drawing is proportional in size. So we shrink the width and the height the same amount, and we shrink it by the same ratio. So let's take a look at this. A scale, let's find the scale on this map. Oh, there it is. Look in the bottom right where that arrow is. 1,000 feet equals the distance that's shown there. Now, we might have different size screens, but on my screen, 1 inch equals 1,000 feet. Might be slightly different on yours. It might not be a full inch, but we're going to go with an inch for this slide. So I want to know how far is it in real life if you go 4 inches on the map. So let's say I want to go from about here to about here. That's about 4 inches on my map. So how am I going to figure this out? Well, let's set up a ratio. So 1 inch to 1,000 feet is my ratio, and that's my scale. So I now want to figure out how much, if I go 4 inches, how many feet would it be? Now notice I have inches all on the numerators and feet all on the denominators. So you're going to have the same units across numerators and same units across denominators. It's very important when you're when you're using a scale. So I need to find a relationship that can help me figure out x. So let's see. I see, 1 to 4 inches. I know how to go from 1 to 4 inches and have an equivalent fraction. I'm going to multiply that by 4. So whatever I do to the numerator, I'm going to do to the denominator. So I have my denominator. I'm going to multiply that by 4, and I get 4,000 feet. So if I'm going to go 4 inches on the map, I'm traveling 4,000 feet in real life. So that's how I can use my scale to help me make decisions about stuff that's happening in the real world. So your turn. So here's the Eiffel Tower. Let's do a shout out to the Eiffel Tower team. Go team. So I've got 1 inch equals 54 meters. So on this blueprint, the blueprint of the Eiffel Tower is 6 inches tall. So how tall is the Eiffel Tower? So let's pause here. You can do this on your own and then come back and you'll see how you did. All right, welcome back. So let's see. So 1 inch, the ratio is 1 inch to 54 meters. Now I know the Eiffel Tower in this drawing is 6 inches tall, so I need to figure out an equivalent fraction, or in this case I have a proportion, where I need to solve for x. So I need to find a relationship where 1 inch over 54 is equal to 6 inches over something else. So if I make those equivalent fractions, I will figure out what x is. Oh, I see a relationship, 1 inch to 6 inches. To go from 1 to 6, I multiply by 6. So now I'm going to do the same to the denominator. I'm going to multiply that by 6, and I get 324 meters. And that's how tall the Eiffel Tower is. Here's a fun fact. On a hot day versus a cold day, the Eiffel Tower can grow as much as 6 inches from the heat due to the expanding metal. So I thought that was pretty cool. So we learned about scale. Now let's learn about scale factor. A scale factor, it's a scale that has the same units, and it's in simplest form. Let's just look back to the Eiffel Tower. We have different units here. We're dealing with inches and we're dealing with meters. But a scale factor has to have the same unit. So here's a slide that shows the difference between a scale and a scale factor. A scale gives a ratio that compares measurements. It doesn't have to be in the same unit. So we've been working with that so far, 1 inch to 5 feet. That's my scale. The scale factor, though, it must have the same units. So you might have to convert your units. So here's an example. If it's 1 inch to 5 feet, I need to convert both to inches. I could convert both to feet, but it'll be easier to do it to inches. So 1 inch, so 5 feet is how many inches? It's 60 inches. So 1 inch to 60 inches is my ratio. So my scale factor is 1 to 60. My scale factor is 1 to 60. And notice I don't have to say a unit in the scale factor, because the units are the same. So I just say my scale factor is 1 to 60. So I didn't mean to put that pause there. Let's go on. So practice. So find the scale factor for the first one. Let's do this one together. 1 inch to 6 feet. So I have inches and I have feet. I need to convert to inches. So I have 12 inches in 1 foot. I'm going to multiply 6 feet by 12 inches. I get 72 inches. So 1 to 72 is the scale factor. Now pause. I'd like you to do the second one and then come on back. All right, welcome back. So 6 inches to 2 feet. Let's see how you did. So you want to convert to inches. 12 inches to 1 foot. 6 inches in the model equals 24 inches in real life. I hope you didn't write 6 to 24 as the scale factor, because remember, you need to simplify. It needs to be simplified. So if we simplify 6 to 24 as a ratio, we could take 6 out of both sides, and we'd have 1 inch equals 4 inches. So the scale factor is 1 to 4. All right, on your own. I want you to, in a minute, you're going to get out of this room. Maybe you're in your room already. I'm telling you, I want the scale to be 1 inch to 2 feet. Go to your room, measure the length and width of your room. If you don't have a tape measure, just estimate it. That's fine. Make a scale drawing of your room. Put your bed in there and one other object in the scale drawing and bring that to class tomorrow. All right, so go ahead and do that, and then come on back for the end of the video. All right, hope you made a nice drawing of your room. So bring that sheet back to you to class tomorrow with your notes, and answer these last questions. I learned or was reminded of, and questions I have are. Hope you enjoyed the video.